Okay, foundations and pre-cal 10. This is often one of the most overlooked, but I would argue important sections we have, and it's called function notation. And we talked a little bit about it when we talked about inputs and outputs. So far we've been seeing all of our equations like this, y equals something, right? What you're going to start seeing now is this notation, an f with an x in brackets. And how it's pronounced is f of x. And what it means is y is equal to f of x. That's what it's all about, okay? F of x is your y values. But we call f of x because it is the function with respect to x. So watch how we run this, okay? What it means here is, if you look here, we have y equals 2x minus 4. So change the y now to f of x equals 2x minus 4. So what this means, this is your function machine, right? Here's your input, which you input into here, and then the answer is your output. So basically, instead of a x comma y, you get a x comma f of x. Input, output, input, output. That's really the whole point. So how we say, like, find y when x is 5, what we've been doing in this scenario is we would just go, okay, find y when x is 5, and we would just plug in 5 for x. We get, okay, y equals 6. We're going to do that again, but we just want to get in the habit of looking at it as function notation. And it says, okay, when I input 5 for x, so I substitute every x in my equation for what's in there now, which is a 5. I end up with f of 5 is equal to 2 times 5, because the x becomes a 5, minus 4. So f of 5 equals 10 minus 4. F of 5 equals 6, which gives me the point 5 comma 6. So you're just looking at it in a slightly different way. Whatever happens to replace the x in your f of x is what replaces the x in all of your questions. If you think of it that way, it's not that bad. So let's look at another couple here. So given f of x is 3x plus 5, same as y equals, we want to know the coordinate of a point on the line for f of 2. So we want to know what is y when x is 2. That is what we're asking here. So we say, okay, well, f of 2 is 3 times 2. So you substitute the x for a 2 and a 2, right? Plus 5. So f of 2 is 6 plus 5. So that means f of 2 is 11. So we have the point 2 comma 11. Input, output. It's pretty nice for that. So now let's look at this one, except in this case, they're saying f of x equals negative 7, which means y equals negative 7, which means that's my output, and I'm working backwards. So this is an equality statement. So in this equation, what they're now telling you is they're telling you that f of x is negative 7. So we can just sub the f of x, and now we solve for x. So minus 5, we get negative 12 equals 3x. Divide both sides by 3. X equals negative 4. So when x equals negative 4, f of x equals 7. So we get the point negative 4 comma negative 7. So that is how function notation works. Now obviously, just like everything we do, it's going to get a little bit more complicated. So let's look at this example. What is f of x? Well, so here's what is f? Here's f of x is 2x plus 1. So they're saying, well, what is f of 3x? Now remember, this is all about substitution. It means if you originally saw an x, you now see a 3x. So this becomes f of 3x equals 2 times, not x anymore, but 3x. So you just sub this for this. plus 1, which gives us 6x plus 1. So that's it. That's your answer. Because we're not solving, we don't have information to solve for it. But that's what f of 3x is. So you substitute every x you see in the equation with the new input. So let's look at this one. What is my new input? My new input is going to be x plus 3. So if you have f of x equals 2x plus 1, you now have f of x plus 3 equals 2 times x plus 3 plus 1, right? All of this gets substituted in where you had an x. And then we get a water bomb, so you get f of x plus 3 equals 2x plus 6 plus 1, so 2x plus 7. It's kind of interesting. I like it. And you see it more and more as your math progresses, especially when you get into grade 12 transformations of functions. And here's a special one, because this actually has applications at the very beginning of calculus. This is how you determine a limit law. But watch this. This used to piss me off a lot. I used to get really confused. But then I realized, wait a minute, I'm just substituting this in, right? So you have f of x, which is 2x plus 1. So then what is f of x plus h? Well, I'm just subbing in x plus h where I originally had x's. So now I have that. So f of x looks like that, and f of x plus h looks like that. So then I just sub into that big equation. I need to know what f of x plus h is. So it's 2x plus h plus 1, and then minus f of x, which brackets here, because it's multi-terms, 2x plus 1, and this is all over h. So now this multiplies into here and into here, and you get 2x plus 2h plus 1, and then this multiplies into here and here, minus 2x minus 1. And what you end up with is, all over h. What you end up with is 2x minus 2x is 0, 1 minus 1 is 0. You end up with 2h over h. Now it doesn't matter what h is, as long as h isn't 0, because it would be in my denominator. Now the h's cancel, and we just get 2. So I'm not going to go into how that works in calculus, but it's how you calculate the derivative. And that is something you can look forward to in a couple of years. But that is function notation. Have fun with this section because it's a bonus, but really important. And after this, we're going to move into solving systems of equations and then factoring of quadratics. Look forward to it. See you soon.